And so basically, rational means what? What's the one word when I hear rational number? What is that? What should that mean? Fraction, perfect. So basically, when I see rational exponent, that just means an exponent that's a fraction. And so we're going to deal with those today. And so real quick, here's the key concept. B to the 1/2 power is nothing more than the square root of b. So whenever you see b to the 1/2, oops, I didn't mean to make it that dark. We'll make it lighter. I'll pick the green. Okay, whenever you see the square, oh, that was even worse. Maybe we'll try the yellow. We'll see if the yellow can be lighter. Well, anyway, I won't highlight it, okay? You can see where I was going, okay? But the square root of b is just b to the 1/2. All right, so now, if I see 16 to the 1/2, that just means the square root of 16, which is 4. Okay, 38 to the 1/2. You don't have the square root of 38, so you leave it as root 38. So let's go ahead and look at this next statement. It says, write each expression in radical form, or write each radical in exponential form. So basically what this means, okay, is that if I have a fractional exponent, I need to put it in radical form. Radical form is this. It's the square root. That's what we call a radical. So if I see 25 to the 1/2, that just means the square root of 25, right? Now, do I know what the square root of 25 is? I don't? 5, good job.
Oh, I was thinking half.
Yeah, remember it's not just half. It's actually what number times itself gives me 25. So in that case, I want you to go ahead and simplify it down. If, for example, this would have been root 26, you could have just left it as root 26. Okay. So let's go ahead and look at 18. Is that radical form or exponential form? That's radical form. So what I'm going to need to do is write that as exponential form. So I'm going to write that as 18 to what? The 1/2 power. There you go. Okay, let's look at the next one. This says 5x to the 1/2. So is this in, I need to put it in radical form, right? Because it needs to have a radical. Now, as I look at this, does the 5 have an exponent? No, so I'm going to leave that 5 alone. The only thing that has the exponent is this x. And so how do I write x to the 1/2? Square root of x. Good job. So that's how you write it. Now, it would have been different if it would have been written this way. If it would have been written this way, both the 5 and the x would be under the square root. Okay, so understand that it matters, okay, if you have parentheses or not. So let's look at this one. Square root of 8p. Good job. Okay, so the 8p, I'm going to raise to the 1/2 power, but since I have 2 of them, I'm going to put parentheses. Nice job. So then I have the 1/2. So that would be your answer. Okay, what's the next one going to look like? Ideas?
Just 2.
2, and then what? X to the 1/2 power. Good. So this is just like that one on the previous slide. Okay, think you can handle that? Should be pretty straightforward. So now what we're going to do is talk about the nth root. Okay, the nth root, basically, notice what it says, for any real numbers a and b and any positive integer n. This is crucial. Positive integer. Okay, a to the n equals b. Then a is an nth root of b. So basically what this means, 2 to the 4th equals 16. So 2 is a 4th root of 16. Okay, so another definition we need to have, and you need to get this down. Your book is going to ask you for the principal roots. The principal roots are nothing more than the positive square roots. So when they ask you to find the principal roots, you don't have to worry about finding the negatives at all, just always the positives. Okay. So let's talk a little bit more about that nth root to make sure that we've got a firm grasp of that. Look at what it says. 16 equals 2 to the fourth, and 16 equals negative 2 to the fourth. Both 2 and negative 2 are the fourth roots of 16, but 2 is the principal root because it is positive. Good. Okay. So when it asks you to find the principal roots, you're only concerned about the positive numbers. So let's see what the next slide has for us. Simplify. Okay, I'm going to show you a way that works for me. All right. I'm going to break down 27. Okay. What do I know about 27? 3 times 9 is 27, right? Can you break 3 down at all? No, it's just going to be 1 and 3. What about 9? I can break down 9 and I get 3 and 3, right? Whatever number is outside the root, like in this case at 3, I am looking to see if there's 3 of any number inside. Is there? There's 3 what? 3's. So there are 3 3's, and that will be my answer. So when you find the cube root of 27, that basically means what times itself 3 times gives me 27. Okay, let's look at another one. I want you to try this one for me along that same thought. I want you to go ahead and enter the answer in on your expressions. You're going to break down 32 and you're going to see what number occurs how many times? How many times am I looking for a number? 5, good. Whoa, stop. Good rise. Break that back up again. Break this bit. Break that down. Okay. Break that down. Chicken eggs. You did take it. Yeah. Oh. Okay. Nice job. Okay, so basically, when you break this down, you can pick any 2 numbers to start with too, and maybe I didn't make that clear on the previous slide. I could do 16 and 2, and then I could do 16 as 4 and 4, and then I could do 2 and 2, and 2 and 2. I could do that. Or I could do 4 and 8. Okay, and then I would break those down, and I'm going to get 5 2's when I'm done. All right, here you go, 64, the cube root. So I'm finding what times itself 3 times is going to give me 64. What times itself 3 times is going to give me 64. Okay, answer is 4. So let's go ahead and talk about that, because I know some of you are like, well, I got more than. If you break this down, because this is what a lot of you went with 8 and 8. And then you got to this step and you're like, whoa. And then you got to this step and you're like, oh, she said by 3s. Okay, so then I count and I see, oh, I've got 1, 2, 3, 4, 5, 6. Well, what's the relationship between 6 and 3? 6 is double 3, right? So what happens if I take a pair here, and a pair here, and a pair here? Would you agree there are 3 groups? Each group is 2 times 2, which is 4. Another way you could do this, if you didn't like that, you got to the end of the step, you're like, whoa, I don't like that. This is essentially what the cube root is. You're finding what number times itself 3 times gives me 64. So what you could do if you wanted is you could start with the ones. 1 times 1 times 1. Well, that doesn't work because that's 1. Then you could do 2 times 2 times 2. That's another option. Then you could do 3 times 3 times 3. That doesn't work because 3 times 3 times 3 is what? 27. So then you could try 4 times 4 times 4. And that actually comes out to be 64. So that's another way. Okay, if you didn't like the factor tree, here's another way that you could do that as well. Okay, let's try this one. What is the square root of 25? Okay, what is the square root of 25? Now you might already know this. You might not even need to write anything down. That's always applied to the first one. Did you get an answer? And so we know that the square root is 25. And so the question is, if you did the factor tree, how could you get that to work? Okay, one of the things about square roots is if there's never a number written here, it's always implied to be a 2. Alrighty, the fourth root of 10,000. I'm going to give you a hint here, okay, as to where you want to start. I'm going to start with 10 and 1,000. Okay? If I were you after that, I would break the 1,000 down and do the same thing. Do 10 and another number. Yeah. Answer is 10. Okay, now one of the nice things is if you kept going in this pattern, you would get 10 and 100 and then 10 and 10. So there's your 4 tens. I noticed though that some of you broke the tens down, and there's no problem with that. We can do that. And I'm looking to take things out in what? 4s. So let's see, I have 1, 2, 3, 4 5s. Okay, so there's a 5. That's one of them. And then I also have 1, 2, 3, 4. 4 2s. So the question is, what do you do with the 5 and the 2? Multiply them, and you get 10. So that's another way. Alrighty, so real quick, we're going to get started in this, and then we'll probably call it good, and I'll let you work the rest of the time. This concept is b to the 1 over n power. So this is a fractional exponent. Remember, again, that's what we were talking about. It says for any positive real number b and any integer n is greater than 1, b to the 1 over n equals the nth root of b. So basically what this is saying that these two things are the same. And we've already done a problem like that. So when it's written like this, 1/4, that is the fourth root of 1,296. So real quick, let's just go ahead and break that down. Okay. 1,296 should be 2, and it's a big number. What is that, 648? Okay, let's break 648 down. 2 and 324. 2 and 162. 2 and 81. What do I know about 81? 9 and 9. I'm running out of room, so I'm going to do it this way. 9 and 9, and then I know 3 and 3, 3 and 3. What am I looking for? Groups of what? 4. So let's see. 1, 2, 3, 4. I have 4 what? 2s. Okay, what else do I have 4 of? 1, 2, 3, 4. 4 3s. What do you do with the 2 and the 3? And you get 6. So that would be your answer. Okay? Alrighty, like I said, I think we're going to call that good. We'll pick up with that tomorrow. So we'll start tomorrow with that. And, oops, here's your first assignment. Now, this will not be due tomorrow, okay? This is your whole assignment for section 3. But this way it'll give you a start. So pages 410 through 411, 18 through 78, the evens. Try and get a good start on this because you can see it is a pretty long assignment. Okay.